In this video, I'll show you how to use n8n and AI to create self-destruct automations in Home Assistant. We'll use Google Calendar to capture any voice or text command, allowing the AI to dynamically write and schedule a temporary automation that automatically deletes itself when it's no longer needed. Alright, our workflow kicks off with the Google Calendar trigger named Create Event, which acts as the communication channel to our AI automation engineer. In the settings, after connecting your Google account, we set the poll times to every minute for a near-instant response. For the calendar, I'm using a dedicated calendar to keep our commands separate from my daily schedule. The trigger on condition is set to event created, so the process starts the moment we submit a request. And notice this handy option, I've set a match term to automation. This is a great pre-filter, telling the node to only pay attention to events that contain this specific keyword, preventing any accidental triggers. Now here's a crucial tip for this specific trigger that's different from many others. I've tested this thoroughly. It doesn't matter if you've just created a new event or not. If you try to test this by clicking Fetch Test Event right here in the editor, it will fail and tell you no data found. This is normal. The only way to make this work is to first activate the entire workflow and then go and create a new event in your Google Calendar, whether you create it by voice through the Gemini app or type it in manually. Before our AI can write any code, it needs to know what it's working with. It needs a complete and up-to-date list of every device in our smart home. That's the job of our next node, the Home Assistant node named Get Many States. The configuration here is straightforward but critical. First, under Credential to Connect with, you'll need to select your pre-configured Home Assistant credentials, which contain your URL and long-lived access token. With that said, we configure the rest, the resource to state, the operation to get many, and most importantly, we make sure the Return All switch is toggled on. This combination tells n8n to fetch a real-time snapshot of every single entity in our Home Assistant instance. By doing this, we're providing our AI with the essential context it needs, the exact entity IDs for all available devices. Okay, we've got our complete list of devices, but it's a mess. It's filled with dozens of attributes for each entity that our AI simply doesn't need. That's where the Edit Fields node comes in. Inside the node, we'll set it to only keep the fields we explicitly define. We're going to keep just two. First, the entity ID, which is the unique machine-readable ID that Home Assistant uses in code, and second, the friendly name, which is the human-readable name you see in your dashboard. This simple data cleaning step is crucial for making our AI both efficient and accurate. So we've cleaned up the data for each individual device, but we have one last structural step before we can send it to the AI. Right now, n8n is still processing each device as a separate item. Our AI needs to see the entire list of devices at once to work correctly. That's the whole job of the aggregate node. The setup inside is incredibly simple. We just set the operation to all item data into a single list. This single setting tells the node to wait for all the individual device items to arrive, and then bundle them together into a single, unified list. With our clean, complete, and now properly packaged device list, we are finally ready to pass this critical context over to our AI. And now we arrive at the core of our operation, the AI agent node. This is where we process the user's request and generate the automation code. In the user message, we provide the AI with two critical pieces of information. First, the user's raw request, which we pull from the summary of our Google Calendar trigger. We use summary because the title of the calendar event is passed to n8n as this value. Second, we provide the complete aggregated list of all our available entity IDs, which acts as the AI's technical reference manual. The logic for how the AI behaves is defined in the system message. This is where we give our AI its instruction manual. We tell it, You are an expert home assistant automation creator. We then give it a very specific task to generate a single, clean JSON object with 3 keys: an automation ID, a wait duration in minutes calculated from the user's request, and the complete automation config code itself. We also enforce strict rules, commanding it to only use entity IDs from the list we provided, and, most importantly, to only output the final JSON object. And to do the actual thinking, we connect a Google Gemini chat model. By providing this model with our detailed job description, we transform a general-purpose AI into a specialized, highly reliable automation engineer. Now, you might be wondering why we need a code node here, especially since the AI agent has a built-in output parsers or JSON. And that's a great question. I tested that built-in function, but found that with the complexity of our required output, it would sometimes fail or error out. So to make our workflow more robust, we're using this code node as a manual data sanitizer. The script inside simply grabs the raw text from the AI, finds the start and end of the JSON code block, extracts everything in between, and parses that clean string into a valid JSON object. This simple node is our safety net. It's a more reliable method that guarantees we get a perfectly clean, usable JSON object for the next steps every single time. With our clean JSON object ready, it's time to bring our AI-generated automation to life. For this, we'll use an HTTP request node, which I've renamed to Create Auto. This node will act as our deployment engineer, pushing the new code directly into Home Assistant. Inside the node, we set the method to post, as we are creating a new resource. For the URL, we're using an expression to target the Home Assistant Configuration API. Crucially, we append the automation ID generated by our AI to the end of the URL. This tells Home Assistant the unique ID of the new automation we're about to create. Of course, we need to set the authentication to use our Home Assistant's long-lived access token. And finally, in the body, we specify that we're sending JSON, and for the content, we pipe in the automation config code from our AI's output. This is the actual code that the AI wrote. When this node runs, it effectively takes the AI's blueprint and builds it inside your Home Assistant, creating a brand new, fully functional automation on the fly. Our new automation is now live in Home Assistant, but our job isn't done. We need to make sure it gets cleaned up automatically. That's the purpose of our next node, the wait node. This node simply pauses the workflow for a specific amount of time. This is where we use the second piece of data our AI generated. In the node settings, for the amount, we're using an expression to pull the wait duration minutes value directly from our AI's output, and we set the unit to minutes to match. This wait node will now pause the entire workflow for the exact duration calculated by the AI. It acts as a countdown timer, ticking away the lifespan of our temporary automation before triggering the final cleanup step. After days, hours, or however long we specified, our wait node's timer finally finishes. It's time for the final act, the cleanup. For this, we use one last HTTP request node, which I've renamed to Delete Auto. The configuration here is surgically precise. First, we set the method to delete, signaling our intent to remove a resource. For the URL, we use the exact same expression as our Create Auto node, dynamically inserting the automation ID generated by the AI. This tells Home Assistant precisely which automation to target for deletion. You'll notice we're pulling this ID from an earlier node in the workflow, since the wait node doesn't pass data through. When this node runs, it sends a single final command to Home Assistant, and just like that, the temporary automation is completely erased from your configuration, leaving your system perfectly clean. This is the self-destruct part of our self-destructing automation. By the way, I've bundled everything from this build into a guide for you. You can find that link waiting in the description. I'm always looking for new ideas, so share what you'd like to build together in the comments. Every like and subscribe truly helps the channel expand. Thanks for watching.